Okay. These lecture slides should be on the website as well, so you can follow along. They're not complete, but that's not going to slow us down today because we're not going to get through it all. So the objectives of this lecture is to get you guys familiar with the basics of web application architectures, and then to become familiar with common web vulnerabilities. We're not going to get to any advanced demos this time, but we'll go into a SQL injection demo and cross-site scripting demo next time for sure. So we're going to give an overview of HTTP, HTTP proxies, the basics of web architectures, and then we're going to go into OWASP. If you do any web security, you do any web development, you have to know what OWASP is. I mean, it's like an unspoken rule. You just have to. And then perhaps 2 lectures from now, we'll get into SSL and SSL script. So HTTP is a stateless protocol. It doesn't keep track of state, so there's no timeouts, there's nothing on the server side tracking, hey, this user is still logged in. HTTP is also completely plain text. HTTP is built off basically client requests and server responses. And these messages are built with headers, and then after the headers is basically the request or response body. So HTTP requests must use a specific request method, and in these methods, the data that's passed to the server in the request is essentially basically a variable equals value pair, and they can be delimited by a number of things, ampersands or commas. And the responses that the server sends use status codes. So there's 2 methods for making requests. The first one is HTTP GET. What you have to know about it is that all the request data is stored here in the URL. So basically, you have the specific resource on the host that you're trying to access. So in this instance, it would be www.exampleblog.com/blog.php ? And then this request data. And that may be used to interact with the database on the back end. So the other way is POST. POST passes all the request data in the HTTP request body. So you no longer see GET here and then the specific resource with the start of the request data. It's actually down here in the body of the request. So there's 5 categories of HTTP response status codes. Anything in the 100 series is purely informational. Anything in the 200 series usually is success. In other words, the most common one is 200. Resource found, here's the HTML page or whatever. 300 is redirection. Perhaps the resource you're trying to locate was previously located here. We're redirecting you to its actual location. The 400 series is client error. The most common one that you should all be familiar with is HTTP code 404, which means resource not found. And then 500 series are interesting for us as vulnerability analyzers because that indicates that something has gone wrong in the server. And that's always interesting. So these are some really common status codes. 200 is okay, and it's usually accompanied by data for a web page to be displayed in the client's browser. 302 usually means the request is being redirected to the actual location of the intended resource. 401 means the client is not authorized for that resource. And I'll cover that in the next slide because HTTP does not, it was never intended to track state. So you could see state as authorized versus unauthorized as being a state of the session. And so that's implemented commonly in cookies. 403 is forbidden, that even though you are authorized for the resource, access to that resource may be forbidden. For instance, it may be on a Linux system, the file system permissions may be 000. In other words, no one has permission to do anything. So the web server cannot serve up that resource. 404, not found, and then 500 series. Basically, something interesting has happened on the server, perhaps even a crash. So like I said, it is up to actually the application developer to maintain state and track state. So this is commonly done with a session identifier, shorthanded to session ID mostly, and is typically passed within each request. So this associates requests within a session and is typically implemented in either the URL, hidden form fields, or the cookie that is stored on the client's browser after successfully logging in. So cookies,
I have a question.
yes.
So sometimes the web page would ask for username and password
Mm-hmm.
dialog box.
Mm-hmm.
And then does this mean it maintains the state of that you have been authorized?
In the server response, say it checks the username and password in the database, and you have indeed logged in with correct credentials. The server will send a response with basically in the header the text set cookie. And what follows after that is basically the variables to store in the cookie. So there are some very common ones, such as the domain and the path and expires. And that basically states this cookie is valid for this domain, for perhaps only this path of directories on the domain, and it expires in this manner, at this date or whatnot. There's other two flags that are worth noting. There's one called short term, which means the cookie never gets stored on the hard drive of the browser. Or long term is that it gets stored in memory and the hard drive. The one that's definitely you guys have to know is the attribute secure. Basically, that means to only send the cookie over an encrypted channel. So cookies are sent with each request. So another very important one is HTTP only. So all this has to be implemented by the developer. On that login page, the action taken afterwards, once that user is authenticated, is they have to send a cookie. They have to send basically the server response code to create a cookie with whatever of these and other attributes that are necessary. HTTP only means that any script cannot access it. So it is very common for malicious JavaScript to take the cookie for your browser and try to send it somewhere else so they can steal it, so they can hijack your session. And so JavaScript has basically a call for accessing that data field, and it's just document.cookie. And that will give that JavaScript the cookie to the document if it's not set as HTTP only. So cookies can be stored on the hard drive, and that location on the hard drive differs per browser and per operating system. During actual communication, while that web page is still open, the cookie will also be stored in memory. It will only be stored in memory if it's marked as short term also. I believe under all implementations. Though I don't know if some odd browser doesn't implement this right. So, and this somewhat brings me to HTTP proxies. Since HTTP is stateless, we can basically set up something in the middle between the client and the server that can pause and play the packets being sent to and from the server. So there are a lot of basically tools that exist out there, and the common ones are Burp Suite and WebScarab. And what you can do is you can set up just a local proxy running on localhost, so 127.0.0.1, and you can point your browser to use that as a proxy, commonly on port 8080, and you can pause and play all your internet traffic and it'll analyze all the raw HTML and HTTP being sent to and fro. So this is in essence what I just explained. Let's see, how much time do we have? About 10 minutes. I'm going to show you the proxy demo next time. That's what we're going to start with. Just going to pick up here. So since cookies are sent with every request, it's really smart to use HTTPS for serving up your websites. That means that all the communication between the client and server is done over SSL, and that's negotiated beforehand. So when you see that login page, it should say at the top of your browser HTTPS. And modern browsers now implement basically a drop-down menu you can click on to see all the details of that certificate, to see all the details of that trust relationship for yourself. However, it is very common for websites to just implement HTTPS on just the login page. Then after that, they drop HTTPS because it was commonly believed that if we support encryption on every page, that's going to slow down our traffic and our users won't use us, they'll go to our competition. I believe it was early last year that Google implemented HTTPS on every single service they have, and it didn't even account for like 0.2% of traffic increase. So that argument is definitely false, that it seriously impacts traffic. So, for instance, on a vulnerable website that only implements HTTPS on the login page, this is what's going to happen if a user tries to access your website and there's a bad guy sitting on the same wireless router, say at an internet cafe or a coffee shop. You're going to log on the HTTPS page. It's going to go over the Wi-Fi. Everyone's going to see it. It's going to get to the server. Server is going to say, okay, that username and password checks out, and sends a reply, and the reply tells you to create the cookie. And then he browses after the index page that he's got in, maybe views a friend's feed and whatnot, and that's being downgraded to HTTP. That next GET request that he clicks on is still sending that cookie because HTTP is stateless. So everyone sees that. The attacker sees that, and he can sniff that cookie and reuse that cookie and hijack your session. So if you have your website set up with strict transport security, it essentially forces HTTPS on every page, and it's a header. And so it completely prevents an attacker from being able to do that easy trick. So here in this slide, I have presented basically a little toy architecture to introduce you guys to some of the things that go on when you open up a browser and visit a web page. Basically, the browser handles the presentation tier most often. And things there that can run that handle presentation could be your own CSS scripts, or rather style sheets, they're not scripts. You can have JavaScript running, ActionScript, VBScript. HTML5 allows some scripting capability, and that has been demonstrated in some recent exploits. And essentially, once you type in a URL and the DNS resolves it, which can be another vector for attack. But let's ignore that for now. You send the GET request, and that makes it over the internet to the server. And usually you have two tiers on the server side. You have a logic tier. Basically, it handles that GET request. It handles parsing the data that is being sent to the server in that request. And then there's a data tier. Sometimes they're implemented on the same machine. Sometimes they're implemented on different machines. But basically, the data tier is some form of a database or a service that allows for accessing data or files. So the logic tier is a common place for many scripting languages that deliver dynamic content, such as PHP, ASP. So statistically, most websites are not secure. The most visited ones, the most popular ones, like Amazon, Google, yes, those are secure. But strictly statistically speaking, the majority of the websites on the internet are absolutely not secure. And attackers use this to find ways to access confidential data that's stored on those websites, and they use these vulnerabilities to also attack other users that visit those websites as well. So they can basically store things like malicious JavaScript, so when you go to that website, it could be completely, harmless website originally, but some attacker could have compromised it and uploaded malicious code that will render on your basically browser, will be run by your browser depending on your settings when you go to visit it. So HTTP was not designed to be secure. When it was invented, it was built for static pages that didn't change, that were basically read-only, and they were meant to be shared between researchers on basically ARPANET. So there was no intrinsic security in this design. There was no concept of sessions at the time. There was no dynamic page support, and all this modern stuff was basically bolted on at one point or another. It wasn't intended to support e-commerce. It wasn't intended to support online banking, taxes, insurance, medical data, and the list goes on and on and on. And I'm going to end at the end of this animation because it really demonstrates what's going on and what the mess with the web is. But throwing it all away and starting from scratch doesn't really help. And that's never a agreeable solution to any problem in the world of security if you work in it long enough. So you have, on the client side, all your internet browsers, and these are applications, and they could be running these executable security mechanisms, as we've talked about. They could be compiled with DEP. They could be running with ASLR. They may or may not be. They could have various other permission settings or problems. And so those can be exploited. And then, let's see what to click. So we've covered things like clickjacking, and that can be used to generate fraudulent ad traffic that bad guys can build companies for. It can be used for also stealing information, posting bogus advertising posts on your Twitter feed, stuff like that. You have cross-site scripting, cross-site request forgery. Anyone who sees your traffic can sniff it. And then anyone who sees your traffic, if it's not locked down with HTTPS, can tamper with your data being sent out. They can also tamper with their own data. So that's why you have to do input validation on the web server side. And on the web server side, you have to deal with basically, you have these various things that are running to support your website. You have some sort of logic that authenticates users, because almost everything has username and password mechanisms to authenticate users. And once you have various groups of users, you have to deal with access control. Some users have more permissions than others. Then you have to deal with almost always a database, and that can store almost always users' username and password information. And usually those passwords get reused, statistically speaking. And then you have the web service itself, and both the web service and database basically layers can be attacked to face websites and present, incorrect information on a website. So the access control layer, you have attacks that are called basically direct object references. Database, you should have all heard SQL injection by now, and we'll cover that next time. Web server, if it's not CH rooted, you could do, and it's set up improperly and developed by perhaps an amateur, you could do directory traversal and perhaps just directly access Etsy password file or the shadow file if it's idiotically set up. And there's XML injection. And then it just gets more and more complicated because that's a very simple model. Now you start dealing with things that are commonly used to display more dynamic content like Ajax, and you have Flash and Flex, and you have Silverlight, and then you have Java applets, and you have so much more. And all these are susceptible to O-days that are happening all the time. And it really is just a giant mess, and the entire problem is a huge mess of an attack surface. So I don't mean to end the lecture on all doom and gloom, but I have to. And I'm going to end it with, I guess, this obligatory comic for next time. Any questions? Basically, this guy's saying, oh, I'm going to hack the database. And the guy's like, yeah. And it's all this typing. And he just goes to Google, how to hack databases. And he's like, whoa, this looks hard. So I'll make it look not hard next time and do a demo for you guys that you can do at home. Any questions? All right. Any questions on homework 4?